Mileage will be continuous. Your mileage will be continuous, but your engine power is a categorical,
Discrete.
I say, or you can say object, or you can say uh, uh discrete, numerical, anything is fine. Okay.
Discrete continuous, we can also say that, right?
Not discrete continuous. Continuous, when you say it becomes a floating point. It can take up any value, any infinite values. But when
Okay, okay.
that's why you should not say continuous.
Discrete categorical, that will be right.
Discrete numeric, you can say.
Okay.
Okay.
Mhm.
Fine. So that we need, okay, so fine, these two are already in right form, but yeah, just because they are both are numeric form, don't treat them both as continuous. Okay. That's what I want to highlight. Coming to the model key, in case if you want to use model key, certainly you see for model key, you have some mix type. So you have to do some encoding over here. Then yes, for registration date, you have to bring it to the right format, derive a feature out of it. Then we have fuel, paint, card. Let's see how should we encode them. Let's pick up one example starting with fuel. Okay, so there I go. Okay, so what I'll do to keep myself very short for those of our whichever features I have to do the encoding. I'm just trying to segregate them out. So I say categorical features, and I do this df dot select d types. Okay, so if you look at here, these are the ones you have to handle. Okay, right now these are the ones. So anyway, BMW, if you really see, let me do that. Cat dot maker dot key, it should be same. So single values, no need to do anything. You can discard the features. Next one is model key. Of course we have to do that, we'll come to it. Okay, let date registration. Okay, how should I handle registration date? Can I consume registration data as it is, or do I have to do any transformation, and what that should be?
We can create three columns with the respect to year, month, and date derived from it.
I think we can get the age of that particular date till now from that feature, because date doesn't give us any thing inside. But out of that, we can pull out the age of the car, maybe.
That's right. Okay, at least you can get the something called registration days. Okay, that means how many days it has been since it was registered, which also says in a way the age of the car, right? From the registration, after registration only the car comes on the road, right? First time, so that will be indicating the car age. So you can create a car age, of course, directly out of it, and also you can get extract year, month, and dates. But again, there will be too much, lot many discrete you are adding again to your data. The better feature is car age. Okay, so okay, so coding wise, if I have to do, what should I do? I mean, you already know Python better than me. Tell me, what should I do that? Or if you, so see, that anyway, I'll do that since we have limited time. What you can do is you can convert it to the date type. If you don't know, okay, let me quickly do it. So pt dot convert to date time. Okay, that should, oh, sorry. Mm, okay, that's my date. It just changed the format, that's fine. And then what do I need next? From today's date I have to get the difference, right? So let me do that too. Okay, or let me save it first, if in case I want to have that feature as well. And then, okay, to convert the age, here I go, import. Okay. Oh, sorry, datetime dot today. If I'm not wrong. Yeah. So that should give me. Okay, awesome. That should give me the difference. Here it goes. Okay. Now, again, this is in terms of days. Now, if you want in terms of weeks or months or year, you can do that transformation from this given data. All right. Or if you know any direct function, you can Google out and you can do that way also. Up to you. So this gives me my car age. I'm calling it car age, this feature. How will I do it? So I call it, how do,
Hi, I have a question here.
yes.
Why are we doing it for like current date? Are we supposed to do it with sold at with respect to sold at column?
With sold it also you can do sold. Okay. So why we are not doing a sold it? Because since it's about you know, second hand, right? See, for example, look at this data. This was registered in 2012, but this is sold in 2018.
Yes.
What that means?
That
I
means
mean,
it's used for 6 years, right?
no, so mostly once the car gets sold, then only it gets registered. I mean, on the owner name, right? But here it's happening way after the registration. So it's basically says maybe it's the second time it's sold.
I'm still not understand what does the sold at means. Whether the car is again sold to someone or I'm not getting this one.
So sold it represents the day when it was sold. Yes, you're right. So the question is whether it's sold one time or two time, we don't know exactly. But it is sold at least once, that we know. So the date, what you see here, what it exactly represents, the latest sold date or the very first sold date, that is not clear. But it is a sold date. So this is a question mark, and that's the reason we are not sure.
Okay.
Okay. Yeah.
Thank you.
That's why I'm not relying too much on sold date. Rather, I'm just relying on registration date. Or think about it. If you think you can connect, you can again create a feature out of it. All right. So, but again, this is not a complete task done. If you look at here, this is date time column. You have to get it in numerical form. Do the transformation. Okay, I'm not doing right now, but you know, basically in pandas how to do. Given this, do the transformation, or I'll get it tomorrow. Right now, since let me jump to the another important point. Okay, so now, okay, fine. You created something like car age column or feature, whatever you call. Fine. This you can convert, it's 1 or 2 line of code, and you can convert it to numeric form in terms of days. Okay, let me also put it's in terms of days. You can also create in terms of week or months or whatever way you think. And then again, so what do you think? Uh, as the card age increases, what should be the price at which it should be sold? Lesser
Le-
price?
Lesser price. Yeah.
Lesser price? Okay.
Yes.
I don't know. What about vintage car? Have you guys heard of vintage cars? You know, the
Yes,
more
yes,
older they go, the price increases for it.
right.
So you have to validate from your data. Maybe so that's true for vintage car. May not be true for the car you business that you or the data set collected from the business where it's happening. So you have to validate from data. How will you do that?
By checking the registration date or something like that, we come to know that whether it is vintage or not, right?
Don't do that. Don't check by registration. Think of the plot in terms of plot. What if I plot the days versus the um,
Price.
price? That should give
Okay.
me an idea overall, right? Okay. So think in terms of plots. That's why to summarize things in a better way, plots or summary tables are there. Okay. Uh, great. Let's go to the next feature. So yeah, I'm still yet to come on model key. We'll talk about that later. Registration more or less done. Yeah, you have to do some transformation, do it. Let's come to the fuel one. So df dot fuel, and then let's say how many values we have. Okay, so we have this 4 values: diesel, petrol, hybrid petrol, and electron. Okay. Now, the question here is, okay, so how will you do now? It's about encoding. Let's understand what you think. Given this and you have to encode, what will you do?
Can we
We
check
can map.
the price, like which has the highest one? Like if the petrol has highest price, then we can code according to the priority one, like 0 for the one which has lowest price, then 1 for the other one, like the highest, second highest one, like that.
Okay, let me rephrase my question. You know, there are 2 type of encoding, level encoding and one hot
One
encoding.
hot encoding. Yes. Okay.
Which one will you go with? Level encoding, one hot encoding, and which and why?
As here less number of features are there, we can go with one hot encoding.
In case of label encoding, it will be get the value like maybe 0, 1, 2, 3, and it will be like ordinal to the model machine. So it can confuse. So basically, we can go for one hot encoding, and we can derive 3 columns from it by dropping first column.
Okay, hold on. I'm not asking. Okay, you're talking about the process, how to do. Fine.
Mhm.
That's okay. You're telling me the definition. My question is, which one should I choose and why? How to do is the next. Of course, how to do, that's what you're explaining. We'll do that next. Um, okay, so you said in level encoding, we assign values like 0, 1 to 3, some weightage. But in one hot encoding, you give same weightage. Fine, I get it. Now, my
Mhm.
question is, in this case, which one should I choose? Level encoding or one hot encoding, and why?
One hot encoding will be good.
Why?
As in the one hot encoding, it will not give any weightage to machine, and
But is
that
that
will be the
always right? I mean, what if I have to give weightage? Weightage giving
weightage.
is the right thing.
But model will automatically uh, calculate the weightage based on the other features.
What if model does mistake? Model is not something, no, person with intelligence, right? Model is just an equation. It works on number. It can give weight is fine based on something which is not supposed to be. So it's always a good idea if you know something should be encoded, level encoded, better you do it. That's why people hire data scientists. If everything they leave on model, even these people know there are so many UDI, some tools, third-party tools where drop and drag, give everything to model and model will give you output. But still they hire data scientists to see if model is doing right thing or to direct model to do right thing.
Like if you want to encode manually, then we have to check the prices. On the basis of that, we can give the priority.
No, so tell me, I'm asking question. I don't know. So should I, what do you think? How will you decide given a feature if it has to encode, whether we should encode through level encoding or through one hot encoding? If you have to decide, on what factor will you decide, on what argument you are going to say, okay, this is best?
I think, Ragini, like we should check with the values. If they're equal, I mean, both carry, not both, if they carry the same importance, then we should go with the one hot encoding, if I'm not wrong. So, like, for example, if you take a female or a male, something like that, and put that as 1 and 0, maybe like 0 is lesser in 1 if you do, I mean, one, I'm not sure, I'm just, let me know.
Okay.
It depends on the value of that particular, like if they're equally important, if the label, I mean, in the values, then we should go with the one hot.
Okay. Okay. Any other answer? Okay, so let me go stepwise. I think most of you are quite correct, but you have to put it in a right way. And okay, so here it goes. That's true. If you already know, like from some, you understand business model very well, and on somebody already told you to do this specific modeling, yes, encoding, go with that. But let's say you don't have any information and you have a column like this for which you don't even understand the meaning. The good idea is, as you pointed, yes, first go ahead and check if there is any weightage. I mean, if you don't know, again, ask the answer from data. Go to data, check if there is any weightage with respect to the target variable. So here, what is the target variable? Price. So what you do for every of this fuel, you get the some aggregated price. See if any particular category has some way highest weightage. Now the question, there can be a question like, what is that threshold that you want to pick to say, okay, they are same or they are not same? Of course, they won't be exact equal. That's not possible. You see, indirectly, I'm trying to say how significant is statistics and knowing the right statistical parameters. So you have to do that. Once you are somehow, let's say you established whether they really have some weightage or they don't have, and then the answer is quite clear. Okay, if they really have weightage as per statistics, then level encoding. If they don't have, one-hot encoding. Is that right? Yes. But in this, so where is the work lying here before encoding? Work lies in analyzing this thing with statistical tools. Okay. And if you see here, I would also say something similar. See, also, if you now come back here, see, it's possible. I mean, just by the column, this variable names, I feel we should try. It should be more of level encoding. Why? Again, there's a logical answer, not just randomly. You see, we already know in real time, electro cars are way expensive nowadays, at least, than any other. Or no, hybrid or petrol should be more expensive than the other one. Correct? In general, right?
Yes.
So if it's a hybrid petrol, I mean, let's say you have same models, two car, same models, except that one is petrol and the other is hybrid petrol. They both maybe were registered in same year. If I'm selling today again, would I not charge way more price for my hybrid petrol compared to my petrol?
Yes, yes. There will be a weightage to this particular.
So you have to say this information somehow to your model too. Look, if everything is same, just there's a difference in the fuel in terms of petrol and hybrid. Don't uh, don't predict same price for both of them. You have to predict higher price for hybrid petrol compared to petrol. So of course, again, this you have to validate from data. But again, I'm in general, I mean, this is real time scenario. I mean, in general, in real time world, we do so. So based on that, I'm guessing, but that I may be wrong. Maybe data is saying something right. So you have to check that. So should we check that, or do you want to try it first yourself? How should I check it? Okay, tell me which metric should I go? What should I do to on the statistical analysis part to validate if this needs to be encoded through level encoding or through 100?
Because the different, I mean, the levels, we have different levels, and each one is higher. There's like a grade or something like that. So here we should go with the label encoding.
Okay, now we discussed, right? Let's cross verify from data before actually doing it. Okay, so let's cross verify from data. Now my question is, okay, I want to cross verify. What should I do? What should I do? Where should I start? What hypothesis should I build? Tell me.
I think we should calculate the percentage of our data values in the fuel with respect to the price, and we can plot a bar graph. In that case, we get the percentage, like for which category we have high price. So that will be the good way.
Come again?
Like
Can you
here
repeat?
in the fuel column, we have four classes, right? So on the basis of these classes, we will calculate the percentage of with respect to price, like diesel with respect to price contribution, petrol with respect to price contribution, So which contribution is high, then on the basis of that we can check which weightage is going to more in which class.
Okay. I did not get it, but I think you are saying something fully. What is
I
the
think
role of
he
percentage
meant to
here? That I didn't get. What is the
he meant
role
to
of percentage?
I think he meant to say that we have to first group the data by these classes,
Okay.
then we have to calculate the mean of the price,
Okay.
mean price for
Okay.
each category. Then
Mm-hmm.
whichever has the highest one, then we have to give more weightage to that. Is that correct, Rupesh?
Right, right. This is the point.
Okay. Okay. Yeah. So, okay. So
We can do
let's
this
see.
by ourselves also, and we can discuss in tomorrow class if you want.
Oh, okay. Okay. Got it. So this is what you said. Okay. Uh,
Yes.
let me plot. I think that will be better to see. Bar plot. Uh, I'm not sure of this. If it's occurring in same order. I have to check it. Diesel, petrol, hybrid. Okay.
I think this is right.
No, it's not right. Okay. It's not right. It's something. I mean, I'm not sure. Let me
Okay,
better
okay.
go by this. So it has first diesel, electro, hybrid, and then petrol. Diesel, electro, hybrid, and petrol. It's same, maybe,
Yes,
but
yes.
Yes,
okay,
it's same.
okay, right. So yeah, you can add the x-axis, y-axis, up to you. Uh, or you can. I think it's better. Okay. Anyway, so okay, fine. So which is being pointed here? What we understand from this plot?
The price of hybrid petrol vehicles are more as compared to electro, and electro has more than as compared to diesel than petrol.
Okay, so is it fitting with our real time situation, how it's working in market?
Yes, hybrid cars are like more costlier than electric than petrol and diesel. Diesel are the one which has
So what
more
should we
prices.
do here? What weightage should we give? Should we give same weightage to diesel and petrol?
No,
No. But here, if you see, the difference is not that great difference that you say they are really different. I mean, of course, mathematically they are two different number, but statistically they are not a huge difference. It's 15,000 and somewhere closer to 15,000.
correct. But if we see my practical situation, like there is a difference of 1.5 to 2 lakhs between diesel and petrol car prices.
But why that's not reflected in data then? Maybe you're right. Maybe the data what they have taken. Uh, I mean, again, it's a sample. So
Mm-hmm. Right.
sampling may be wrong. Okay. So yes, or maybe this is the nature. Maybe this is some different market. Uh, maybe it's US market, and there that does not happen. So you have to ask this sort of question. Okay, that's what I'm trying to say. Maybe again, even I don't know the right answer, but again, these are the open questions which can come up. So anytime before taking decision, make sure all open questions, possible open questions that you can ask, you have asked, and you have some answer that could be supporting a hypothesis or that could be going against. That's okay, but there should be some answer. Making sense? You're getting right the bigger picture. Okay, so Again, it's again a lot of open questions. All of us can have some different opinion because it's quite subjective. I am saying this not, I mean, according to me, from statistics point of view, this difference and this difference is not a huge, statistically huge difference or significant difference. Okay, it's like same weight as I can give to it. Okay. Again, there can be a question like, okay, why mean? What if I take median? Will this be different? I mean, one step again, you can try. Just take a median and plot it and see, is there a way difference in the statistics that you see, or it's more or less similar? That will prove if you have outliers or not in your data, significant outliers. Okay. So that also can be one open question. Second, again, okay, again, see one more thing. You also have to take care that number of samples of each of this car fuel type, that's balanced. For example, what if there is a only two hybrid petrol? It's obvious, and more or less their prices are high, so average will be quite high. I mean, in the data, if there are just two models of hybrid petrol, let's say, total two records or three or four, can you check that? How many records you have for each of this fuel type?
Yes,
Yes,
value count.
value counts. Hybrid petrol we have 8, and diesel we have 4,000 approx something.
Okay, let's quickly check that. Okay, and yeah, something I got. See, for electro, you have just 3 cars in your data set. Out of that 4,800, only 3 of them are of fuel electro fuel type, and 8 are hybrid. Petrol 191, diesel 4,641. It's a huge difference. Can you see?
Right.
Clearly, electro and hybrid petrol, they're outliers. Okay. In terms of the other samples you have, I mean, it's rarely that if your model will be able to distinguish between hybrid until there's just some striking feature. Okay, until there is something way striking feature that distinguish hybrid petrol features from diesel and petrol, then only it will be able to do a good prediction for hybrid petrol and electro prices. Else it will give some average price closer to that of diesel and petrol. Do you agree?
Right. And if we do the scaling on this,
Mhm.
basically on this feature, then I think it will be the balance that
It's
way.
okay, it will be balanced, but then does that make sense? Now the first here the question is statistically this itself is imbalanced. Whatever you do, you can do something and get it fine, but is
But
this
if we
correct?
but if we do scaling also, it will not be balanced data, right? Just we are scaling the values for it. We are bringing the values to the same scale.
That is okay, that is okay. uh okay, you can try, see, I don't know, try and see if it's satisfying all the things that we are discussing. According to me, it's that is next thing. Okay, scaling is like when you know your samples are sufficient enough, then you do scaling to avoid the mathematical scaling effect. Okay, that's the purpose of scaling. The purpose of scaling is not to, I mean, the question we are discussing, I think that there it has no significant role. For modeling, yes, it has.
Right, right.
So now what should
Do
we?
we can we
Mhm.
like do here upsampling or downsampling
No, no,
like
no,
that?
no, no, no. Please, no, no. Uh, no. It's even, what will you do if you do upsampling? Maximum 3 records you can take. Downsampling, maximum 3 records you can take. So upsampling, downsampling does not make sense. Okay, that is only when you have sufficient data during modeling. We are talking about here things where we have to encode. So this will not. So what should we do? What will you do in such situation? Of course, you have to ask for more data. okay, to come up with a significant, statistically significant conclusion. Mathematically, yes, you can do anything, but we have to go by stats. So you should ask for more samples for these two categories again to actually come build a robust model. I'm talking real time scenario. Here to proceed, I'll pick up anything and go. That's fine. See? So, but in real time, you should ask for more data. Okay, the one or two samples are not enough to conclude anything. Okay, those could be just coincidence, or those could be, in this case, again, let's say, still, if I have to do some prediction in this, what would I do? What would I suggest as a data scientist the best thing to do? Let's say I go back to my management and I say, see, I cannot do the prediction. I mean, the prediction for electro and hybrid petrol would be wrong. I mean, of course, something, sorry, unreliable. This should not be done. But he'll say, okay, still come up with a model. So what would I recommend? Or what would you recommend? The Let's say he says, okay, I don't have more data. Still, I need some model to show. What would I recommend then? I would say make it a binary class problem. Just build a model on petrol and diesel car at this stage. I mean, for the prediction of diesel and petrol car price. Don't do it for hybrid and electro hybrid. Whenever we'll have sufficient data, we'll include these two classes as well.
Okay, yeah, right.
Okay, right, guys. But again, that's one of the alternative solution that you can propose. But again, if you still want to do, assuming again, now ignore the fact that you have just 8 records, 3 records. Still, you have to do, assuming that you have something balanced data. Now you can give more weightage to hybrid petrol. You can give them next to electro, so maybe 3, 2, 1, 1 or 1, 0, up to you. Okay, but you see, the type of the open questions that are there, it's up to you. You want to discard them or you want to solve them. Of course, with the limited data we have, we cannot solve them, but in real time you have to solve them to proceed forward. Okay, right, so that's how you can choose to do fuel encoding. And more or less for fuel in general, business model wise also, there should be level encoding rather than uh, one hot encoding. And right, is that right? Okay, so you can do not a one line of code, no, just map function, and that should work. So I'm leaving it. Let's go to the next discussion on paint color. That's how our data has the paint color distribution. You see, you have almost 1600 cards of black color. Then 1200, roughly 1200 gray, 600. You can also convert your plot in terms of percentage. That's okay. And then blue, and you have very few green, orange, red. Okay. Now, this is the data you have. You have to encode them. What should you, again, given that we already have some idea now, suggest me what should I do? Which sort of encoding? Do you think level encoding, again, let's, of course, one
I
thing is
think we should go with label encoding again.
for the reason.
Like we have to check whether this color has any impact on our price. Like if we say practical scenario, like the color has an impact on the price also.
Okay. So that's right. You have to, if you have to check it and then decide. And then it's easy, right? Once you are certain what encoding you have to go. And if you have some statistical fact behind it, done. That's how it works. Okay. So yes, that again, it will take time in that statistical establishment, but encoding should not take time once you know what you have to do. Right. So I leave that up to you. You come up with this best optimal encoding based on the statistical fact. You analyze yourself. All of you can do in, of course. Uh, each of us can think differently, come up with different questions, think the same problem with different way. So let's see what you come up, and tomorrow we'll decide majority has gone with which approach. Okay. And then we have also card type, okay, and then sold it. We'll talk about them tomorrow, okay. So I'll stop here. I know a lot of the coding I have not done, but hopefully it gave you an idea to which direction you have to look for. And um, I would I would recommend all of you to do this part by tomorrow on your own before I share some code on it. That will be great, okay. And then we'll discuss further tomorrow. I'll stop here for today. If any of you have any questions, let me know. I'm here for next 5 minutes, and I'll take up your question. Rest all of you. Thank you guys for joining, and let's meet tomorrow.